Hello, everyone. Welcome to the 20th World Congress of Psychophysiology. Uh, this is the symposium for the regulation of affective and social behaviors. Tonight, we have invited six young but talented scholars working in this field, and they will present their most up-to-date research. The topic ranges widely from the relationship between depression and social reward to the neurocorrelates and their underpinnings of memory suppression, as well as social computation or emotional recognition, as well as the topics related to social isolation and their substrates of major depression, and also the motivational impact on emotional regulation preference. And this is the schedule, the schedule for tonight's event. And now, the first speaker is Dr. Gu Ronei from Institute of Psychology, Chinese Academy of Sciences. His topic is the relationship. His topic is the relationship between depression and social reward. Let's welcome.
Sorry, I can still not, I'm still unable to share my screen.
Okay, now you can do it. It's okay.
I'm afraid not. It still says someone else is using the screen.
Let me check it.
I guess it's you. Okay. Okay. Can you see my PowerPoint?
Yes.
Yes. Thank you. Sorry for the interruption. Thank you, Chairman, for inviting me. I very much appreciate the opportunity to share some recent findings to you about the relationship between depression and social reward. Professor Dandan Zhang from Shenzhen University and I have finished 2 experiments on this topic. We all know that reward plays an important role in our everyday life. Searching for reward is a primary motive for not only human beings, but also animals. But compared to animals, the reward for human beings show a much higher diversity, such as money, academic grade, and international fame. In this page, I list some major kinds of rewards that we are most familiar with, including food, money, addictive, and romantic rewards. These kinds of rewards are important to our daily life because if there is no reward, we may have no motive to do many things. However, for depressive individuals, many of them have a syndrome called anhedonia, which means they have difficulties to experience happy feelings associated with reward. This syndrome could result in various behavior problems. In this page, we could see a list of the key symptoms of depression, including inability to feel pleasure. That is exactly the definition of anhedonia. Our recent studies focus on the impact of anhedonia on the processing of social reward, including positive social stimuli and social interactions. By positive social interactions, here are some examples. We get to know new friends from workplace. Our work performance is acknowledged by some authorities. All the photos we share on social network receive much attention. Our first question is, we know that anhedonia in depression influences the processing of both social and non-social reward, but we do not know whether the influence in these 2 aspects show the same or different patterns. This issue is inspired by previous findings that social and non-social decision-making have overlapping brain mechanisms, especially the dopamine reward network, including the ventral striatum. For instance, in this picture, the green part indicates brain activation associated with money reward, whereas the purple part indicates brain activation associated with social reward. As we could see, they are almost within the same area, that is, the ventral striatum. In this meta-analysis, the authors compare previous neuroimaging data between different kinds of reward, and the conclusion is the same. However, these results are based on brain imaging techniques, so they mostly focus on the spatial dimension of brain mechanisms. In our opinion, the temporal dimension should not be forgotten, because reward processing is a very complicated cognitive process, which means it requires the participation of different brain areas, not just a single region. Neural signals transmit between these areas in a high speed, usually just a few milliseconds. Therefore, even though social and non-social reward processing employ the same brain areas, the temporal relationship between these areas may not be the same. For this concern, our studies rely on EEG, which could help unravel the temporal dimension of brain activity. There have been many studies investigating the impact of depression on brain activity using brain imaging or EEG. Please see this review for details. To address this topic, we use a classic paradigm called Monetary Reward Delay Test, MID, MID for short. In each trial of this MID test, you would first see a queue indicating the amount of reward you could receive or the amount of punishment you could avoid by successfully finishing the ongoing task. That is, a target stimuli would appear at the center of the screen for a very short time. You are required to press the space button within the time window of the target. Finally, there will be a feedback indicating if you are successful or not. As we could see, this page represents the correspondence between different kinds of queues and reward amounts. This paradigm has been applied in the field of clinical psychology for many years. Then from 2009, some researchers have updated this paradigm for social neuroscience studies. In this revised version called the Social Incentive Delay Test, SID, money rewards are replaced with social rewards such as a picture of smiling face or a thumbs up. As you could see in this SID test, the negative feedback would be a picture showing disappointment expression or something alike. So, by asking participants to finish both the MID and SID tests, we could directly compare the processing of money reward and social reward. In this study, our sample consists of a depressive group and a control group. The depressive group were college students who scored high on self-reported depression scales, but they were not diagnosed for any kind of emotional disorders. That is, they were subspecial depressive individuals. These are the behavioral results of the first study. In short, we find out that in the reward condition of the SID task, especially high social rewards, the depressive group show a lower accuracy than the control group. Meanwhile, in the MID test, there was no significant between group difference. The interaction between the two factors, the grouping factor and the reward time factor, was significant. Accordingly, our conclusion is that the impact of depression on social reward processing is stronger than that on money reward processing. We collect not only behavior but also ERP data. In this page, we could see an ERP component, contingent negative variation, CNV for short, which is invoked by Q presentation. This component indicates subjective expectation to the upcoming target. We find out between group differences of the CNV amplitude in the SID task, but not in the MID task, which show exactly the same pattern with our behavior results. In addition, the correlation between behavior performance and CNV amplitude was significant in both groups. The influence of depression on social reward processing could help explain some behavior syndromes associated with depression in daily life, such as social avoidance. Our second study is largely based on the first one. We have just learned about the importance of social reward in daily life. But if for some reason we are unable to get a basic level of social reward, we may feel lonely, depressed, and all other kinds of negative emotions. These emotional problems are prevailing in some social service institutions, such as nursing home, because in these institutions, patients are almost isolated from the society and therefore lack of social interactions. To deal with this problem, some people suggest that we could rely on intelligent artifact agents, which we know as robots. Nowadays, thanks to the development of modern techniques, we have many kinds of robots that could interact with people in some ways, as you could see in this picture. Recent studies have pointed out that this kind of human-robot interaction would be good for mental health, such as increasing subjective feeling of happiness. So our next question is whether depression would influence not only human-human, but also human-robot interaction. To explore this question, we focus on the SID task, but provide two kinds of social feedback. As we could see in this page, in one condition, social feedback is from human beings, which was consistent with our study one. In the other condition, social feedback is from a robot, which could simulate different kinds of emotional expressions. These are the major results. In the human condition, we could still detect the influence of depression on both behavior and ERP data, which replicate our findings in study one. However, in the robot condition, the between-group difference was insignificant. Finally, the two-way interaction was significant. Accordingly, we suggest that depression modulates social reward processing under human-human interaction, but not human-robot interaction. So these are the take-home messages. First, compared to non-social reward, depression affects social reward functions more strongly. Second, in the domain of social reward, we find out that compared to human reward, the processing of robot rewards is relatively intact among depressive individuals, which might be a good news. So thank you very much. Your question would be highly appreciated.
Okay, and we really appreciate Dr. Guru Lei's wonderful talk today. Our next speaker is Dr. Hu Xiaoqing from University of Hong Kong. His topic today is neurocognitive mechanism of emotional memory suppression. Just now, I detected that Xiaoqing is now online. Well, warmly welcome, Xiaoqing. Now it's your platform.
Yeah, thank you, Professor Yuan. So I'm now going to share my screen. Let's see.
Julie, have you stopped your screen sharing?
Yes, I have.
Okay, okay.
Okay, so let's see. Yeah, can you see my screen?
Yes. Wonderful.
Okay, cool. Okay, so I'm gonna start presenting my point. So first, thank you very much, Professor Yuan, for organizing this excellent opportunity for us to share our recent research. So today I'm going to talk about some of our recent studies on the neurocognitive mechanism of emotional memory suppression. And this work was led by my graduate student, Lin Xuanyi. So we know that like memory is a very important question to understand the human mind. And in the 125 years of the science, we proposed, the community proposed 125 fundamental research questions. On the top list is how our memory is stored and retrieved. So this is almost like 20 years ago. But recently there is a shift of the research focus. So now many research started focusing on the biology of forgetting. And last 2 years ago, 2019 is the 150 years anniversary of Nature. So the journal Nature published the anniversary collection. And one of the paper on cognitive science and human mind is the memory editing from science fiction to clinical practice. So as you can see here, starting from understand how memory are stored and retrieved, now we're looking at how we can forget and how we can modify unwanted memories. So the philosopher Nietzsche once said, blessed are the forgetful, for they get the better even for their blunders. We know that in our daily life. We know that in our daily life, there are many memories that we would rather forget. So for example, it can be like interpersonal conflict. It can be like some unpleasant experience make us sad, distressed, or it can be like a traumatic event, for example, a car accident. And we know that for successful memory control, it can help us regulate our emotions and preserve self-image, and also facilitate interpersonal forgiveness. However, if the memory control is less efficient, then it is tightly associated with a variety of psychopathology disorders. For example, PTSD, which is characterized by intrusive images, flashbacks, and depression, which is characterized by uncontrollable rumination, and anxiety, which is characterized by excessive worry. And insomnia is also characterized by uncontrollable thoughts, so they cannot fall in sleep. And also a recent study showed that people who has high resilience after trauma also have high memory control efficiency. So in this study, they recruit a special population of participants. So those are the people who are exposed to the 2015 November terrorist attack in Paris. And in the next 8 to 18 months, so they look for participants who were exposed to the attack, but either develop into PTSD or non-PTSD. So the PTSD minus and PTSD plus. And they recruit the participants and give them the memory control task while their brain is under fMRI scanning. So this is a TNT task for the experimental task. And as you can see, this is a typical think, no think experimental task we typically use in the lab. So the results, as you can see here, is quite astonishing. So for they focus on functional dependency. So how different regions of the brain are connected during the think, no think paradigm. As you can see, for those exposed to the trauma and develop into PTSD, PTSD plus. So the functional dependence is quite weak between the prefrontal region and the hippocampal region. But for the people who are exposed to the trauma but did not develop into PTSD, so those are the individuals we call with high resilience. So they showed this like particularly strong connectivity between the frontal cortex and the memory-related network. So this result suggests that an efficient memory control ability is crucial for us to maintain mental health after being exposed to trauma. So a lot of neuroimaging study have been conducted with the TNT paradigm, and most of the results found that during memory suppression, we will rely on our right medial prefrontal gyrus to have top-down control of the memory-related regions, for example, hippocampus, and the neocortex that is implicated in pattern completion during cortical reinstatement. And if the memory is very strongly emotional, so the right medial frontal gyrus will also have top-down control of the amygdala responses, so to attenuate emotional reactivity. So most of the research finding used the functional fMRI to look at where in the brain does memory control happens. But as Professor Gu just mentioned, timing is also a very important factor. And we, to complete the picture of how memory control works, we also need to understand when does the top-down control happen and how exactly does it suppress unwanted memories. So my graduate student, Lin Xuanyi, conducted his work with EEG. So we asked the question, how specific is memory control? And when we want to ask the question, how specific, we want to use multivariate EEG patterns. So we know that typically when we do ERP analysis, it tells us excellent information along the temporal processing. However, unlike fMRI, they cannot tell specific information. But when we do multivariate EEG pattern analysis, it can tell us item-specific information. And second, how fast. So to take advantage of EEG's millisecond temporal resolution, we want to ask, like, how fast can people suppress unwanted memories? So we build our work on this neurochronometry in recall. So basically, it proposed that upon perceiving a memory cue, and within the first 500 milliseconds, and the perceptual input will activate hippocampus, and via pattern completion process in the hippocampus, it will lead to cortical reinstatement, so help us retrieve the episodic memories. So in this paradigm, we use emotional memory think no think. So here each cue is paired with one negative image. So here, as you can see, is a dead body, and here is also a dead body, and here is a street bully scene. So here's our behavior results. As you can see here, compared with baseline, the red no think has been associated with lower recall, so telling us that our retrieval suppression manipulation was successful. So people can successfully forget unwanted negative emotional memories. So next, we examined the ERPs during the think-no-think paradigm. So we look at ERP components linked with cognitive control and linked with episodic retrieval. So we found pretty consistent evidence, with previous studies, that no-think, the red line here, is associated with attenuated P300 and late positive potential. And also we found that in terms of cognitive control, we look at the frontal central region, the no-think is associated with enhanced N450. So because N450 has been associated with enhanced cognitive control, so we take as evidence that no-think trials elicit enhanced cognitive control to suppress unwanted memories. And we also found that the lateral prefrontal cortex, the negative slow wave has been associated with retrieval suppression. So retrieval suppression led to attenuated negative slow wave activity over the lateral prefrontal cortex. So here are the conventional ERP analysis we conducted. So as you can see, most of the results are pretty consistent with the prior results in think-no-think paradigm and ERP. So we next move on to the multivariate analysis. So this is a spatial temporal ERP topography. So the first thing we do is we want to see whether we can use multivariate decoding to see whether we can distinguish between different conditions. So think, no think, and perceptual baseline. And we found that when we use all the 64-channel EEG information, we can do the decoding very highly successful. As you can see, the decoding accuracy starts as early as almost like within the first 100 milliseconds and stay very high throughout the temporal course, the recording epochs. So for the think versus perceptual baseline, no think versus perceptual baseline, and think versus no think conditions. And also we found that for the think versus perceptual baseline decoding accuracy has been linked with the retrieval-induced remembering. So the more of the EEG signals distinguish between think and the perceptual baseline, the more likely people are going to have a better memory for think trials. So this validates our first hypothesis. So we can use whole brain EEG signals to distinguish between different conditions. But next, the question is whether we can distinguish between individual items. So this figure showed the neurodynamics for item-specific cortical patterns. So as you can see for the think trials, we can identify individual items throughout the epoch window. But for no think, the decoding accuracy is only significantly above chance, between 0 and 1,000 milliseconds. But after 1,000 milliseconds, the decoding accuracy dropped to chance level. So if you compare between think and no think, it's pretty obvious evidence that for no think trials, people we can no longer decode individual item from their whole brain EEG activity. And a similar thing is for the perceptual baseline. Because there's no memory activity here, there's no significant decoding after 1,000 milliseconds. And also when we showed the topo, as you can see, the first 500 milliseconds, the significant decoding was driven by occipital region activity. But in the later from 500 to 3,000 milliseconds time window, it is driven by the parietal, occipital, and also the prefrontal cortex activity. And also higher of the decoding has been associated with a higher memory score for think trials. However, for no think trials, if we look at the first 500 milliseconds, they still show a significant above chance decoding, but mostly over the occipital region. Probably people are still reflecting that people are still perceiving the object Q here. The interesting thing is that, and also the important thing is that after 500 milliseconds, when people are supposed to retrieve the memory, and we can no longer see any significant electrode contributing to decoding, suggesting that indeed people can stop the retrieval and keep the memories out of the mind. And then as a validation, we look at the perceptual baseline trials, which showed highly similar pattern to the no-think trials. So from these results, we found that the suppression can weaken and even abolish item-specific cortical patterns. So when we directly compare items, like item decoding in the think and the no-think trials, we found the difference lies around 500 milliseconds. And also, this activity has been associated with a different topo map. As you can see, during this time window, around 500 milliseconds, in the no-think trial, there is a significant activity in the occipital region, parietal region, and prefrontal region. But in the no-think trials, it's only significant EEG activity over occipital regions. So this result tells us at the time, for the precise timeline, suppression significantly reduced item-specific cortical pattern around 400 milliseconds. And next, we look at the individual differences. So we found that for the high forgetting, so those who can successfully forget unwanted memory, and the difference is very early, like as early as 300 milliseconds. But for the low forgetting group, for those who did not forget unwanted memories, there is no significant difference between the two conditions. So when we compare high forgetting versus low forgetting and no think versus think trials, the significant difference arises from the early time window, suggesting the earlier, the faster you can control unwanted memory, the more likely you're going to be successful in voluntary forgetting. So this result tells us a rapid and sustained suppression leads to strong suppression-induced forgetting effect. So the take-home message is, if we ask how specific can memory suppression suppress memories, so our results suggest that retrieval suppression can abolish and item-specific cortical patterns based on whole brain multivariate EEG analysis. And if we ask how fast can people suppress unwanted memories, then our results show that retrieval suppression weakens item-specific memory before 500 milliseconds upon seeing the cue. Probably it interrupts the cue to memory conversion processes. And the successful forgetting requires both rapid and sustained deployment of top-down control on individual unwanted memories. So I think with when we're combining EEG findings and fMRI findings, so we have a richer understanding of how memory control happen in the brain. So in terms of which part of the brain were engaged, and how fast will the brain be engaged in suppressing unwanted memories. So last, I want to thank my lab group members and for my funding support. And thank you very much. So below is my email. Feel free to email me if you have any questions. Yeah, thank you very much.
Okay, thank you very much, Xiaoqun, for your wonderful talk. Our next speaker is Ni Song and Professor Ni Song and his student from Nanjing University. Now, Xiaoqun, please stop your screen sharing. Now it's turn for Yan Song's student. No voice. Chenxi, please open. We cannot hear you.
The topic of my presentation is understanding the power of competition, insights from its impact on forced memory. The process of memory is affected by the social environment in which it is memorized. Social factors affecting memory include social pressure, memories of social interaction, and social conformity. In real life, there are far more social environmental factors that affect memory. So it is necessary to further explore other social environment factors that affect memory, such as competition. Competition often occurs in environments, memory competitions, such as 26 World Memory Championships 2017 China final competition. Contests compete through memory tasks such as names and faces, binary numbers, random numbers, abstract images, speed numbers, historic or future dates, playing cards, and written words. In our daily life, people can remember the items they have studied or events that actually happen to form true memories. Memories can be easily distorted to produce false memories, which can have serious consequences for some events. Competition is an important form of social contest and social interaction, which can affect the shaping of memory. Therefore, it is necessary to further explore the influence of competition on memory. Does competition increase or decrease memory performance? Studies has pointed out that our competition reduces the level of working memory. That is, competition reduces the level of true memory. So how does competition affect false memory? At present, there are no researches to discuss, which is worth our study. In response to the questions of how competition affects false memory, our team published a paper in Psychonomic Bulletin and Review. How does social competition affect true and false recognition? We used a version of DRM paradigm to measure the first true and false recognition. The task consists of 3 phases: a study phase, a disaster phase, and a test phase. During the study phase, participants were asked to study 10 lists of 15 related words that was not present in the list. These words were presented in the center of position of the computer screen at the rate of 1 word every 2 seconds. After the study breeze, participants performed the disaster breeze. This was involved in 5-minute buffer activities in which participants were required to solve simple arithmetic problems. Following the disaster phase, participants then performed the test phase. During the test phase, we administered a recognition memory test. The test list consists of words belonging to 3 types of test items. 20 targets, for example, all the items from the study list, 10 related disasters, and 20 unrelated disasters that were not present in any of previously studied list. Participants were asked to respond yes or no to each item. In the competition condition, participants were led to believe that they were competing against an opponent on the DRM paradigm while 2 linked computers. To further intensify the contest, they were informed that if their performance in the task was better than the opponent, they would receive the bonus payment of 10. The results showed that hit rate for targets and false arms to related disasters was significantly lower in the competition group than in the control group. To investigate the potential relationship between true and false recognition, we performed correlation analysis between hit rates for targets and false arms to related disasters in the control and the competition groups. The results revealed a significant connection between hit rates and for targets and false arms to related disasters. In the results revealed a significant correlation between hit rates for targets and false arms to related disasters in the control group, but not in the competition group. The results that the semantic processing contributes to both true and false recognition in this group, which is consistent with findings from previous studies using theory, seems to give a better account of memory processes because this theory assumes a relationship between the true and false memory. We failed to find a significant correlation between them in the condition group. What changes have been taken place in the semantic relatedness of the control group? Studies suggest that orbital traits have been found to be important in social competition. According to fast trace theory, enhanced orbiting-based processing would reduce the accessibility of guested-based semester traces during retrieval, resulting in the non-significant combination in the competitive contest. The result of signal dictation theory shows that participants in the competition group should a significant lower DP for first recognition. This indicates that social competition seems to encourage item specific processing or relational processing based on fuzzy trace theory, an enhanced item specific processing and the enhancement of verbatim-based processing may reduce the activity of related disasters or the accessibilities of guest traces during retrieval, thereby increasing the likelihood of recognition rejection and result in a reduction in false recognition. In response, bias participants in the competition group related to the control group showed a market shift towards a conservative response basis for both true and false recognition. To sum up, this study used DRM paradigm to explore the impact of social competition on true and false recognition. We find that participants in the competition group showed lower levels of true and false recognition than those in the control group. We failed to find a significant correlation between false recognition and true recognition in the competition group. According to first trace theory, an enhanced verbatim-based processing would reduce the accessibility of gist-based semiotic trace during retrieval, resulting in a non-significant correlation between true and false recognition in the competitive contest. Signal dictation analysis reveals that participants in the competition group exhibited a decreased sensitivity for false recognition, which implies enhanced items of specific encoding during social competition. Moreover, Participants in the competition group showed a more conservative response biases for both true and false recognition at retrieval than those in control group. Thank you for your attention.
Okay, thanks to Professor Yan Song and your student Chen Xi. Our next speaker is Professor Zhang Dandan and Dr. He Zhenhong from Shenzhen University. The topic is social isolation is associated with smaller gray matter in amygdala in major depression. Let's welcome.
Sorry, the screen cannot be.
Chen Xi, have you stopped screen sharing? Please stop your screen sharing. And then Dr. He can start. Okay.
Okay, can you see the screen, the PowerPoint?
Yes, very clearly.
Okay, thank you. So, thanks, Professor Yuan, for holding this symposium. Today, I would like to share my recent work named Social Isolation is associated with smaller gray matter volumes in amygdala in people with major depression, a UK biobank study. So let's start from the background. As we all know that the impairment of social functioning is an important feature of major depressive disorder, or we can call it MDD for short. It is pervasive and encompasses nearly every aspect of one's social capabilities, leading to such as the unemployment, disability, and decreased working performance. Further, this social dysfunction can persist even after 3 years of remission from depressive symptoms. Thus, it is proposed to be a trait of normality. Therefore, a better mechanistic understanding of social dysfunction in MDD has potential important implications for clinical practice. There is accumulating evidence that feeling of social isolation or exclusion, or we can call it social pain, could be a critical factor in explaining social dysfunction in major depressive disorder. Social isolation and MDD are strongly related. For example, you can see here that social isolation plays a prominent role in the risk of developing MDD. Also, social isolation increases depressive symptomatology. Inversely, you can see here that increases in depressive symptomatology predict loneliness. So, taken together, these findings therefore suggest a reciprocal relationship between social isolation and MDD that has a negative impact on mental health and well-being. So, the social isolation is a subjective experience commonly evoked during social isolation or social exclusion situations. The neuroimaging evidence of social isolation have investigated the neural basis of perceived social isolation or exclusion. Indeed, the dorsal anterior cingulate cortex, or we can say DACC for short, amygdala, and ventrolateral prefrontal cortex, or we can say VLPFC for short, have been identified as critical brain regions related to social isolation or social pain. Specifically, the DACC and amygdala are associated with experiencing social isolation, while the RVLPFC, or say the right portion of VLPFC, regulates this experience via inhibiting the response of DACC and amygdala. However, the activity of these brain regions is altered in people who report MDD. So, for example, increased ACC, amygdala, and VLPFC response are observed in individuals with major depressive disorder when they experience social isolation. which may in turn contribute to their abnormal emotion responsivity and regulation of loneliness-related information. However, although there is strong evidence linking social isolation and functional alterations in ACC amygdala and VLPFC, evidence on its association with potential structural changes in those regions is limited. Therefore, the present study aimed to examine how social isolation is associated with brain volume, or say gray matter volumes, GMV, in regions that are important for social isolation related regions, such as ACC, amygdala, and VLPFC. And we also test the difference between MDD patients and healthy controls. So we here use the UK Biobank database. The large-scale uniform protocol samples make it possible to draw robust conclusions in the sense of differing study methodologies. So in this analysis, we use the imaging data from the UK Biobank. This includes 21,402 people who underwent structural brain MRI with measure of regional GMVs. To avoid the potential effects of extreme values, we exclude any participants with outlier GMVs defined as values plus or minus 3 standard deviations from the group mean in any brain structures from the analysis. We also remove participants with self-report diagnosis of severe mental illnesses, neurological or neurodevelopmental disorders, such as bipolar disorder, schizophrenia, Parkinson's disease, stroke, dementia, and autism. Further, we exclude participants with missing data for one of our key demographic or behavioral variables, age, gender, education level, etc. After these exclusion procedures, it remains has 18,446 participants. So here is the definition of MDD agencies in this study. This was generated from previous published and validated criteria. All individuals categorized as having the recurrent major depressive, including the moderate or severe, were used for the MDD sample. So the social isolation variable was summed from the responses to 3 questions from the UK database. According to the UK Biobank database, so the MRI acquisition, pre-processing, and imaging analysis were all conducted by the established UK Biobank protocols. And we also we are lucky to use the imaging drive phenotypes generated by an image processing pipeline derived by UK Biobank. So here we use 6 metrics of regional GMVs, including left and right ACC, left and right amygdala, and left and right bilateral VLPFC. So the statistics methods is the regression analysis. So it was to use to assess the relationship between social isolation and GMVs of ACC, amygdala, and VLPFC in MDD patients and EHCs, or healthy controls. So here we adjust the age, sex, education, and brain size. And false discovery was used to correct for multiple testing. So here's the demographical information. And the main result is that we can see here in MDD patients, greater social isolation was so significantly associated with reduced GMVs of bilateral amygdala and right VLPFC. However, in healthy controls, only the left amygdala GMV was related to social isolation. And we also conducted an interaction analysis. It found that stronger association between the social isolation and GMV of right amygdala in MDD compared to healthy controls. So our finding indicates that brain structure important for processing or regulation of social isolation may be altered in MDD patients. However, we cannot determine causality of this relationship, but we could say that the association between social isolation and volume of the amygdala and RVLPFC suggests a clear biological correlate of feeling of isolation. Findings also indicate the negative effect of social isolation on brain health in depression. Thank you for your attention and listening. And here is my personal email. You can contact me if you have any questions.
Okay, thanks to Dr. He Zhenhong. And now please stop screen sharing and let's welcome next speaker, Dr. Jianming Yang from our lab of Sichuan Normal University. Her topic today is motivational impact on emotion regulation preference and its cognitive pathway. Let's welcome. Professor Yang, please share your screen. Thanks.
Okay. Wait a minute. Okay, have you seen my screen?
Yes, clear.
Firstly, thanks for Professor Yuan's invitation. I'm so honored to participate in the symposium. The title for my talk is Motivational Influences on Emotion Regulation Preference and its Pathway Studies. And this is the outline for my talk. Emotion regulation is defined as the processes to modify any component of emotion processing. Typically, it consists of three cases: upregulation of emotion regulation, maintain a given magnitude of emotion response, and the third case is most well known to all of us in daily life. That is down-regulation of negative emotion by some specific regulatory strategies, such as distraction and reappraisal. Distraction means diverting or disengaging our attention, mind, cognition, and awareness away from the emotionally invocative events. It can result fast and initial emotional reduction, while its weakness is insufficient processing of emotional events. So it cannot generate long-lasting events. By contrast, reappraisal leads us to reformulate, reinterruption the meaning of the emotional events in multiple ways that we can reinterpret it from a neutral or a positive perspectives. Previous study has been established its long-term emotional regulation effect at the cost of the cognitive resources, because reappraisal will need the cognitive control of mechanism to be involved for the successful reappraisal. Another aspect should be mentioned is the motivational dimension of affect. That is, in addition to the well-known dimensions of valence and arousal, motivation in recent years has been established to be the third independent and also primary dimension of affect. It can be organized by two dimensions, namely motivational direction and motivational intensity. Motivational direction represents the drive to approach a goal or avoid an object. Motivational intensity refers to the strength of the motivation, which ranges from the low to high to a given motivational direction. Those are some typical examples for high versus no approaching or high versus no withdrawal motivations, such as craving, serene, and so on. And previous study has been established the close association between motivation and cognition. To be specifically, that is, motivation intensity of emotion negatively predicts attention breadth. That is, increased motivational intensity is associated with narrowed attention breadth, such as when we come across some fearful things and we are motivated to withdraw and keep us away from the threat. Our attention is narrowed, focused on the threat, so we cannot pay attention to other things. And also, if we are craving for something that we wanted very much, our attention is narrowly focused. Our target, such as candies and cookies, something like that. Under such circumstances, we cannot have attention resources to pay attention to something else. And also, previous study has established that attention breadth can positively predict creative thinking. That is, our attention is widened, our creative thinking can be broadened, and we can think something normally we cannot think about. As we know, creative thinking requires reformulating the meaning of the stimulus in multiple ways. Therefore, it's closely related to the reappraisal. Therefore, if we take the 3 lines of the evidence together, we can have an impression that perhaps the motivational intensity can influence the emotional regulation choices, especially the emotional regulation preference for reappraisal, and probably by the root of the attention breadth. However, this hypothesis has never been tested by previous studies. Therefore, the current study wants to investigate the motivational effect on emotional choices, especially for reappraisal. And after the phenomenon has been confirmed, we will go a step further to examine its cognitive pathway underpinning this effect. Therefore, the current study includes 2 lines of experiment. Experiment 1 aims to set up the phenomenon whether there is a significant impact of motivation on emotion regulation preference. To be specific, we want to study whether motivation intensity or direction will moderate emotion regulation choices, especially between distraction versus reappraisal. Another one aims to study its cognitive pathway after the phenomenon has been confirmed. Therefore, the study 1, the materials consist of 116 pictures. It's evenly distributed into the 4 conditions according to the motivational direction and motivational intensity. This is for examples corresponding to high withdrawal motivation picture versus high approaching picture, and no withdrawal versus no approaching pictures. And we have recruited 13 participants to participate in the study. The outcome variables is the reappraisal percentage. It is defined as the number of the reappraisal choices against the total number of the 14 choices. It started with the 500 millisecond fixation, followed by 500 millisecond pictures. Then after perception of the picture, subjects are required to make a decision between the 2 emotion regulation choices. One is reappraisal and the other is distraction. After that, the emotional picture will be presented again for 5 seconds. Then subjects need to rate their degree to use their strategy using 7-point scale. The manipulation check shows that here we can see it clearly that our manipulations of the motivational intensity and the motivational direction are successful. We also counterbalance the ratings of the arousal and the ratings of the valence between the high approaching and no versus no approaching, and high whistle versus no whistle. And we can find is that we set up a clear influences of motivation intensity, but not a direction on the emotion regulation preferences. And by this figure, we can see that high versus no motivational intensity is associated significantly reduce the choice of the reappraisal. However, this influence is not found for the motivational direction effect. After the first step, our study 2 aims to establish the role of attention breadth in the emotional intensity on emotion regulation preference. Use 47 subjects. This is the study stream 9. And that is for the first step. Subjects need to perform a classical global local task. That is the figure used in the task. The figure on the top is the target. The subject needs to choose between the two items on the bottom. Which one is more similar to the target? If subject choose A, we can say that the A shared much more global characteristics with the target, means that participants pay attention globally to the figure. The choice A corresponds to the global choice. It corresponds to the higher attention breadth. By contrast, the choice of B, we can observe that its local feature, that is square, it is quite similar to the target. So the choice of B corresponds to more attention to the local feature, corresponds to the redacted attention breadth. The emotion induction for the first step, followed by the global local test. The key finding is that for the first step, we can see high motivation is associated with net global based choices. And the figure in the right panel shows that high motivation versus no motivation is associated significantly less reappraisal. Therefore, if we summarize the key findings here, we can say that increase with the intensity contributes to less global based attention, that is reduced attention breadth, and also it contributes to less appraisal choices. Therefore, the third step, we want to fully explore whether attention breadth can serve mediation role in association between motivational intensity, the effect on the emotion regulation choices. And here we can see clearly that in the root A, that is motivational intensity, effect on attention breadth is significant. And also, attention breadth can positively predict their emotion regulation preference for reappraisal. And this effect is significant after isolating the direct effect of motivational intensity. And we can say that this mediation is a partial mediation. As after isolating the effect of attention breadth, the directed effect is still significant. Therefore, we can establish the partial mediation of attention breadth in explaining the motivational intensity effect on emotion regulation preferences. If we can summary, the first conclusion is that increased motivation is associated with more preference for distraction over reappraisal during emotion regulation. Therefore, increased motivation narrows one's attention breadth, which in turn contributes to less choices of reappraisal during emotion regulations. So, motivation matters in the choice of emotion regulation strategies. This is my report. Thanks for your attention. This is my email address. If you have any question, you can contact with me.
Okay. Thanks to Professor Jamie Yang for this clear report on her recent work. And now, all the talks for this symposium are now well done. We need to deliver our special thanks to all the speakers for their wonderful talk and also for their clear effort for preparation for this talk. Tonight, because tonight's event is a video pre-recording prepared for the IOP online conference. Therefore, we do not allow chances for a live question and answer session. However, this session can be late, but it will never be missed. And so we want to tell all the lovely listeners this evening. And just 1 week later, please pay attention to IOP online conference. And there will be a special session for question and answer. And at that time, all the speakers will be online and will answer all the questions proposed by all the listeners. Thank you very much. And thank you for all the speakers' efforts. So now it's over. Thank you all.
I'll see you.
Bye-bye.
Bye-bye.
Bye,
Bye-bye.
everyone.
Thank you. Bye.
Thank you. Bye-bye.
Bye bye. Bye bye.
Bye-bye.